Hello. So what we have here today is power jack 300 watts PSWGT-300 grid tier inverter. Another thing, never try to repair such kind of things if you do not know what are you doing, because high voltage can kill you. And even if it is disconnected, those capacitors can be charged and may kill you. So don't try to repeat. All responsibility is on your own. Mostly it is used for solar panels. It takes 14 to 28 volts input of DC to this, and then pushes the output to the 220 volts grid. That way electricity flow is going to the electricity grid. Here we have the input voltage, then it converts voltage to high voltage, to something like 220 or even more, and then it measures the waveform in the grid and matches waveform the grid by using those four MOSFETs. I have read in the internet that most common problem with these inverters are that one of these MOSFETs goes short. It happens when the grid is unstable or it has some spikes. Then it pushes voltage into the back to the inverter, and it results in the dead MOSFET. And also we have a fuse here. It also usually goes bad when this situation happens. This inverter was already fixed some time ago. It has one MOSFET changed and a fuse, new fuse, but it got different problem. Now the MOSFETs are all good, but even red light doesn't light, and nothing happens at all. It's like completely dead. Another thing what is done, what manufacturing what did for this inverter, that they peeled off all the marks on all the chips. It is not possible to see what kind is this chip, this one or this. But I have some information gathered from internet and will share it. Okay, here we have a voltage regulator. It is LM3171. It drops voltage to something like 10 volts. Then we have another voltage regulator, this one, small one here. It is U678L05. It drops voltage to the 5 volts. Then we have a capacitor, and these 5 volts goes to microcontroller. Microcontroller itself is unknown, but I suppose that it is at mega 328p, or I just think so, because the pinouts of this chip here completely matches at mega 328p, which is Arduino Uno. it looks very similar. Okay, and here we have U2 chip. It is a PWM controller. I got this information from the internet. It could be SG3525A. Another small chip is this one. It is marked as U4, and it could be LT1013D operation amplifier. In other side we have 8 diodes, and those diodes are RHRP 8120. Okay, then we have 4 MOSFETs for the DC part, and those are STP75 and F75A. And for the high voltage, for the AC line MOSFETs, we have FB11N50A. I read in the internet that people are changing those MOSFETs to higher voltage MOSFETs. Those are rated to 500 volts. They are changing those MOSFETs to higher voltage MOSFETs, and it helps to prevent this inverter of going dead. Also, I read that when you are disconnecting this inverter, if you disconnect AC line first, it goes dead. Commonly. So usually you should try to disconnect DC line first, and only then disconnect AC line. This was a recommendation from the internet, from other people. But as I told, the problem in my case was completely different. There were no even red lights turning on when connecting the DC line. So I found the problem, and it was crystal oscillator. But the thing was that markeration on it also cannot be seen. So I tried quite many of them till I found one which is working, and here it is, and it is 16 megahertz crystal oscillator, and inverter started to work. In addition, I just added one more fuse, external fuse, soldered it to the AC connection and to the PCB, just for the additional protection. Another thing, I see that I found that one of the contact was almost touching the crystal oscillator pin on the PCB, and it is negative contact of DC input, this one. So I shortened it. I cut the screw just to be sure that it will not touch the PCB. Okay, so let's try to test. Let's start from 12 volts with no AC grid line. Okay. Okay, so we have red light, fault. This is normal, as we have no grid connected to the inverter, and we have 0.3 watts. Okay, and here we have AC line. Let's try to connect it. Okay, something happens. We see that green lights start to flash, but not normally. Let's increase voltage. 30 volts, 13, 14, 15, and LEDs starts to flash normally, one after another. And I hear inverter. Okay, in the input we are giving 33 watts, and inverter pushing to the grid 28 watts. Okay, let's make one more test. Here we have a wattmeter and the extender connected to it. Here it is, and we have LED lamp to 220 volts. I will connect it. So LED takes 10 watts. Inverter is connected to the same meter here, and let's try start the inverter at very low current. We see that it takes 1 watt from the DC input, and we see that wattmeter showing drop of consumption. Let's increase current a little bit. I'm increasing current on the input, and you see that consumption from the LED is dropping down. Let's increase a little more. It's just a test to show that inverter is putting power to the mains grid. Okay, so we have same LED lamp, and now it takes only 5 watts because other 5 watts are injected with the inverter. Let's try a higher power. I have set current to 10 amps. Voltage is low at the moment. The inverter is not working. Let's increase. Okay, and the inverter starts pushing to the grid. 42 watts, 45. It's increasing. Let's put more voltage. 17 volts. 88 watts. 96. 105. Okay, 129. Let's increase a little more, but it's already on current limit. And that's it. We have 150 watts to the input, 132 watts to the grid, and we have lights on the inverter flashing very fast. Please like and subscribe if you like the video. Thanks, bye.